Hi guys, our topic for today is about similarity in right triangles. Let's start. In number 1, given that triangle ABC is similar to triangle DBC, what is the measure of BD? So we're looking for BD. I can write BD as X since we're solving for BD. And remember class that the first thing that we have to do is to separate two triangles. So I can say that I can compare the smallest triangle, which is triangle BDC. It is important to include triangle BDC because BD, side BD, is included in triangle BDC. Okay? So I'm gonna draw the small triangle. Okay? So we have BDC, wherein BC is 15, DC is 9, and BD is X. Another triangle that we can use is the biggest triangle. And the challenge here is identifying where is letter A, where is letter B, and letter C. So that we can visualize it, I'm going to show you how to flip this. So it requires flipping the triangle, okay? So for example, in this triangle, since our goal is to have the right angle on the bottom left, I'm going to flip this triangle horizontally, and then I'm going to rotate it. As you can see, this is the triangle that we want to have a right angle on the bottom left. Now I know that angle A is on top, angle B is the right angle, and angle C is in the bottom right. Okay? And also based on this figure, I know that AB is 20, and BC is 12. Okay? Now that we have the two triangles now separated, we can now compare and make a proportion using the sides. So what corresponds with side BD to the other triangle? Yes, that's side AB. So I can say that X over 20, okay? So I'm going to write it here. X over 20 is equal to, another side that we can compare is the side BC, which measures 9, and also side BC, which is equal to 12. So I can write here 9 over 12. Now that we have the proportion, we can now solve this using cross multiplication. X times 12 is 12x. 9 times 20 is 180. 9 times 20 is 180. And then divide both sides by 12. So 12 divided by 12 is simply 1. And 180 divided by 12 is equal to 15. So since we set BD as X, therefore the answer is 15. BD measures 15. Next, for number 3, if VZ is equal to 28, so VZ is the measure of the entire the biggest hypotenuse. It measures 28. WZ measures 20. WZ, okay. XZ measures 7. Solve for YZ. Since we're looking for YZ, I can name this as A. And we're going to solve for A. So like what we did earlier, we're going to separate the triangles. So I can say that the biggest triangle is triangle VWZ. That's the biggest triangle. So I can draw it here. VWZ. Okay. So we have VWZ. We know that VZ measures 28. So I'm going to label this as 28. Okay. And WZ measures 20. So I'm going to label this as 20. That's the first triangle. Next triangle is the smaller triangle, which is triangle XYZ. Okay. So I'm going to draw triangle XYZ. XYZ. Where in XZ measures 7. And YZ, the side that we're looking for, I'm going to write this as A. Now that you can see the bigger triangle and the smaller triangle, we can now create a proportion. What are the sides that we can compare? 28 corresponds to 7. So I can create a proportion. 28 is to 7 is equal to 20 corresponds to A. So equals 20 over A. Now that we have a proportion, we're going to solve for A. So cross multiply. 28 times A is 28A is equal to 7 times 20 is 140. And then divide both sides by 28. 28 divided by 28 is 1. So we have A here is equal to 140 divided by 28 is 5. So our answer is 5. It means that YZ measures 5. Okay, for number 5, if MN measures 20, PN is equal to 8, solve for LN. So LN is the hypotenuse of the biggest triangle. That's what we are looking for. So since we're looking for that, I'm going to write this as X. So again, like what we did earlier, we have to separate the two triangles. Since we are looking for LN, I know that I need to include the biggest triangle here, which is triangle LMN. So first I'm going to draw the triangle LMN. This is triangle LMN. And we can see here that LN is X. So I'm going to write this as X. And MN measures 20. Okay, so that's the first triangle. Now we have to draw the second triangle. I'm going to use this triangle, triangle MPN, just because the numbers here are already present. I cannot use triangle LPM because there's no number involved here, okay? So, again, the challenge here is how to determine the angles, okay? So we have to shift or rotate this triangle in order to become this triangle, okay? So to better visualize it, I'm going to use this program, okay? So remember, we're looking for triangle MPN. So what I'm going to do is I'm going to flip this horizontally, and then I'm going to rotate it there. There you go. So from this figure, I can see the triangle MPN, wherein P is in the right angle. So I'm going to write here as P. Okay, and then the one on top is M, and the one on the bottom right is N. We can also see here that MN measures 20, and PN measures 8. Okay. So now that we have our two triangles, we can now write a proportion, wherein X corresponds to 20. So I can write X over 20 is equal to 20 corresponds to side PN, which measures 8. So I can write 20 over 8. Now that we have the proportion, we're going to solve for the value of X. Cross multiplication or butterfly method, X times 8 is 8X is equal to 20 times 20 is 400. Okay? So now solving for X, I'm going to divide both sides by 8. So 8 divided by 8 is 1. So we only have x here. And 400 divided by 8 is 50. Okay, so now we know that x is equal to 50. And again, class, x is the measure of ln, the measure that we're looking for. So ln is equal to 50.